We run into
All right.
it all the time.
So,
But it's probably, if it's gonna be first and reading, we might have to go through.
so we're gonna get started. We're still talking in here about stuff. So, this is where I was talking to you about that sine and cosine are more than just your opposite over hypotenuse, adjacent over hypotenuse. They're actually waves as well. So what we're gonna do is we're gonna develop the graphs for both of these today. And really the way you develop a graph for anything is we just plot points. So we are going to make a t-chart for sine. Now, let's think about what we need to pick for x's and how we're going to get our y's. And we're going to do this all by hand. So my question would be, what do we need to pick for x's? Like 0, 1, 2, 3, 4, are those going to be good choices?
Yes.
You sure about that? Okay.
Oh, wait.
So let's say we pick 1. That means I have to do sine of angle 1.
Yeah.
I
So
don't know
what if it's, 90, 180?
Oh, okay. Now here's the only problem with that. So you're on a better track now, because now you understand that x must be an angle. But the only thing is that when we plot in the Cartesian plane, if we're using x's and y as our rectangular coordinates, that has to be straight line measurements. So what normally when we go to make our x-axis, right, this is a distance here. You can't put 90 degrees as a mark. So you can't put 180 as a mark because you've got to go circular. So let me just piggyback pi over, yeah, just use a radian measure.
Oh, okay.
So what we're going to do, you got the right idea.
Yeah.
We're just going to use radians now. So, and so why did you pick 90 and 180 or pi over 2 and pi? Why would you pick those? Why not pick 30 degrees, 45 degrees, 60? I'm asking, is there a reason that you picked these? Anybody can answer that.
Quadrants?
Yeah, right?
Each quadrant.
Yeah. I mean, that's not a wrong
I
answer.
was thinking of the coordinates on the circle plan.
It's very good, because it's going to be easier. We're going to use the unit circle. It's easier to get the outputs quick. Remember the unit circle. So I'm going to put the unit circle here, because that was, remember when I taught it, remember I drew that picture trying to show the circle unraveling to create the wave. So that was the idea. So if we put the unit circle, and I'll put the measurements in radians, 0, pi over 2, pi, 3 pi over 2, back to 2 pi. What were the coordinates? That's a bad circle, that's okay. What's the coordinate here?
0.
Yeah, 0, you're right. I'm just gonna put the y, right? Because sine is only the y coordinate. What's the coordinate here? 1. What's the coordinate here for sine? 0. And what's the coordinate here? Very good. So let's erase that. And now, since 0 is an angle, let's start with that. Instead of just going straight to 90, let's start with 0. And then let's do pi over 2, pi, 3 pi over 2, then back to 2 pi. And go ahead and use those as your inputs, and then get your sine answer, and then we're going to plot those points. And then I'll talk about how we can plot those on the x-axis. Should go by fairly fast, right? So sine of 0, what do we get? 0. Remember, it's the y coordinate for the angle. That's why we're highlighting the y coordinate, right? So 0. Sine of pi over 2, what do we get? 1. Sine of pi, what do we get? sine of 3 pi over 2, what do we get?
-1,
Alright. Sine of 2 pi, what do we get?
0.
Now, alright, let's just stop for there for right now. Now, what did we say about 1 and -1 in terms of the outputs for sine? What does that represent? 1 and -1 for the outputs for sine. So when you do sine of an angle, and you get 1 or -1, what does that kind of represent? It's the largest answer you can get. Because most of the time you're doing opposite over hypotenuse and you're getting fractions. So 1 and -1 are your boundaries. Your whole wave should be within there. Now, how is it that I'm able to put pi over 2? Well, pi over 2 is a half of pi. So it's past 1 and it's before 2. See, it should go somewhere, right? It should go somewhere on the XY plane. Now, I'm not gonna put 1 and 2. I'm just gonna put our intervals of pi. So pi over 2 is approximately the number 1.57, right? It has to be rounded because you're truncating pi. It's half of pi. So it's somewhere in here. But it is on the x-axis. Remember, the x-axis represents all the real numbers. So pi over 2 is a real number. It's irrational. It's about there. So instead of trying to plot, where is it in relation to 1, 2, 3, 4, I'm just gonna put the marks, intervals of pi. See, each increment here should be 1/2 pi. So if I do another 1/2 pi, I should get to what? Pi. If I do another 1/2 pi, 1, 2, 3/2 pi, or 3 pi over 2. And then another 1/2 pi, 1, 2, 3, 4 half pies, four half pies, which is 2 pi. There you go. Okay? And then we can just plot 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, 2 pi 0. And if you connect the dots, you get a nice little wave like that. And what you're gonna see is that this goes forever like this. So, and what's the I promise I'm gonna run out of camera room here, but we'll go backwards in a second. How do I know it does this forever? Like its next move should be this. See, this part here should be the same as this part.
It's like a revolution, so it just keeps going.
Yeah, if I go around the circle again, I'm gonna get the same thing. See, now, I'm 2 pi, see I made it here? So if I go here, this is 5 pi over 2. See, 5 pi over 2. 1/2, 2/2, 3/2, 4/2, 5/2 pi. 5/2 pi would be there, 5 pi over 2, do the same thing. So I'm not gonna keep going. But let's at least go that way and mark these down. So what would these increments be if I go this way?
Negative?
Yep, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Now, and you get those by going how around the circle?
Clockwise.
Clockwise, so this is negative pi over 2 and so on. So why don't you take a second and get those, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, let's get those outputs. So I think you can just do this by looking at the circle. What's negative pi over two? What's sine of negative pi over two gonna be? Negative one. Sine of negative pi. Sine of negative three pi over two, and then sine of negative two pi.
0.
You see, you get the same thing. Okay? So, here's what I would like you to picture. This piece here, if we just take this, right, if I had a computer, I'll put the mouse here, right, like I had an image, I wanna copy an image. Think about it like that. If I copied this and pasted it here, would this not be the exact same? And this is how the sine graph works. This is just copied and pasted forever. It's a wave that goes forever. So you can't draw the whole graph, it's impossible, you can only draw a piece of it. And what we wanna know is what's the piece that repeats itself, and it's this piece here. So this is said to be one cycle for y equals sine x from 0 to 2 pi. And this is the piece that we would keep, this one cycle here. Okay? So there's many things that can be graphed using sine and cosine functions. Alright? One is, have you studied in science like a spring and a weight? So what would happen if I, imagine that I had a spring, right, think like a slinky, right? And I pulled the weight down, I let go, I'm just stretching it, what's the weight gonna do? It's gonna go up, then down, and up, and down like that. Now eventually it will taper off because of, it doesn't do that forever. But at the start, it kinda has this, the height of the spring is relative to, you can use a sine graph to do it. But it damps, it doesn't keep going like that forever. What's that?
Gravity.
Yep. Alright, so, okay, so there's that, we'll save that, alright? Now, there's some things that we talk about with sinusoidal functions, these waves. So now there's some, what's the word I'm looking for? Scientific terms, okay? So one term is this, it's the amplitude. And the amplitude is always the height of the wave divided by 2. Now when I'm talking about height, I'm talking from top to bottom, not above the x. So this would be its height. So how many units is that? How tall is that?
2.
2. Yeah, 2. Now, but 2 divided by 2, so you get an amplitude of 1. Okay? So I want to for this. Okay. So here's what we're going to do. We are going to now repeat this whole process. So we'll save this. So I'm going to go over here to the side. And I'm just going to put this. Y equals sine x 0 to 2 pi, because I can't graph all of it. And I'm just going to put that one. So I usually just put pi, 2 pi first. Then I put the halves. Then I put my 1 and negative 1. And I just go through and draw it. Okay, there's that. So there's my one cycle. Okay. Alright. There's another term that we'll use. Period. It is the x distance for one cycle. So for this one cycle, remember one cycle is here to here. Alright? How far is that? Horizontally.
Isn't it 2?
Not 2. 2 pi. 2 pi. X distance for one cycle is 2 pi. So we say sine is 2 pi periodic. Okay? We'll write all that stuff down later. I'm just introducing those definitions. Okay. Now, I'm going to go through the unit circle. I'm going to erase all these coordinates now. And now I'm going to put which coordinate? Yeah, the x. We're going to highlight the x's. So this is 1, that's 0, that's negative 1, that's 0. And now, since we saw that we kind of wanted the negative outputs too, we're gonna redo the chart here, and now we're gonna do the chart for cosine, but we're gonna start at negative 2 pi with the x's, so here we go, cosine of x, so we're gonna go negative 2 pi, negative 3 pi over 2, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, 2 pi. I would probably do these first, and then go backwards. And then, but I'm just trying to put them in numerical order, and then we'll plot this. Should go by fairly fast. Okay, so let's go through and put the values. What did you guys get for cosine of 0? 1. Cosine of pi over 2. 0. Cosine of pi.
Negative 1.
Cosine 3 pi over 2.
0.
Cosine 2 pi. 1. Alright, so 0, 1. Alright, this x is 0, y is 1. Pi over 2, 0. Pi negative 1. 3 pi over 2, 0. 2 pi 1. Okay? Now, I know it looks like a V, but it's not a V. It's rounded, right? This is still gonna be a wave. And then what do you think is gonna happen on the other side? Yeah, it should be hopefully the same pattern. So when we go negative pi over 2, cosine of negative pi over 2, you should get 0. Cosine negative pi, negative 1. Negative 3 pi over 2, 0, and then negative 2 pi back to 1. So all we're doing is we're looking at the angle, right? And what's the x coordinate? That tells us cosine. So negative pi over 2, 0. Negative pi, negative 1. Negative 3 pi over 2, 0. Negative 2 pi 1. And if you plot that, now, what do you notice? What's that?
It's a reflection.
Can you be more specific?
It's reflected over the y-axis.
Remember, it goes forever, so it's symmetric about the y. So it's gonna, so yeah, so if you kind of looked at that as a cycle, if I copy and paste this, yep, it's here. Well, remember our even and odd. The identities that we derived the other day, we said that cosine of negative x equals cosine x. It's even. Well, let's see. That means if I put in, let's just do cosine of negative pi, is that equal to cosine of pi? Well, let's see. Cosine of negative pi, we're here, negative one. Cosine pi, we're here. So that's what that means, okay? Alright. Is it still a wave? Yeah, I mean, if you just keep taking this, so this is what I would call one cycle. Okay? If I just keep copy and pasting that, I'm gonna get the same thing over and over again. So it's like half of a crest, a valley, half of a crest, which is still, now look, if I did this, and I didn't have any numbers, what would you say that is? Look right there.
Half a unit circle.
No. Look, yeah, well, look at the picture. What does that look like? I can't stand like this forever.
A mountain.
It's on the board somewhere. Look on the board.
A sinus.
5,
I don't know.
4. Look, it's the same picture there. Sine of X.
I'm not sure what you were covering.
Look,
Yeah, I
I'm
couldn't
covering,
tell.
look.
Are you talking about like just?
What's left? Right
Okay,
there. What does that look like?
That over there.
There, it looks like sine. It's just, it looks the same. They're just shifts of each other. See, look. So if I do this, here, try it like this. Let's see if this helps.
Got it.
Yep, got it.
That's painful.
So, is cosine of x, that's cosine. It looks like sine would be shifted left. So it looks like it equals to sine of x plus pi over 2. To shift left, you would have to go plus, right? So if I took sine and shifted it left, or we could say this, if I shifted cosine right, so if I move cosine this way, is cosine of x minus pi over 2 equal to sine of x, and that would be true. If I move cosine right, so those both kind of either way, one should equal to the other. Okay. Alright, so, I like doing this, so a couple of things. I'm gonna put our one cycle, we don't need unit circle anymore, it's done its purpose, right? Remember what I said to you about the unit circle, like what you were saying, those 4 points is key, and I use those a lot. So what I'm gonna do, one cycle for y equals cosine x, 0 to 2 pi. And I'm just gonna draw half a crest, a valley, half a crest. Okay, and notice what are the y boundaries for cosine? What's the highest cosine can be? 1. What's the lowest?
-1.
And it still has amplitude and period. Now this is what I like to do. So I like to show students this. We'll save this I'm gonna come back to this in a little bit. Let's do this. Let me put the whole cosine graph back up here in blue. He did.
Oh!
It's only taken 23 years to make the basket. Alright, there's that. That's cosine, right? Let's do sine in red. See? Now you can see they're very close to each other. The same thing. That's why they're grouped together as sinusoidal functions. Okay? They're just a shift of each other. Bruh, it's DNA. Not really, but.
It's close.
Now, so let me again show you what I was trying to say. If we take cosine and move it this way, it should land on sine. Would you agree with that? So if we take cosine and shift it right, if we take cosine and shift it right, half of a pi, it should equal to sine. Now, for cosine, because of this, cosine of negative something equals cosine of the same thing. Means that if I did cosine of negative 30, it should equal to cosine of 30. If I do cosine of x minus pi over 2, it should equal to cosine of pi over 2 minus x, which is the opposite. Okay? And this is one of your identities. That's your cofunction. See, cosine, you have it 90 minus theta equals sine theta. It's the same identity. Pi over 2 is the same as 90. All connects. Okay? Alright. Now, so, I'm not gonna, obviously, if I try to memorize this, it's gonna be crazy. I'm gonna be like, oh my gosh, what's going on? So this is all I do. Basic graph of sine, just keep copying and pasting. Basic graph of cosine, just keep copying and pasting. Okay? How do I get, what's amplitude? Amplitude is the what?
Full length divided by.
Height of the wave divided by, so both of these have what amplitude right now? What's the period? Horizontal distance for one cycle, what you can say for cosine, one cycle is just u. Because it just does it over and over again, and that's also 2 pi. So they're both 2 pi periodic. So now, what we're gonna do, does everybody have their calculator handy? Okay? It's a rhetorical question, that means get your calculator out. Alright, okay, I'm gonna erase these notes here. We're almost done. So all I'm gonna do today is we're gonna look at vertical stretch and vertical shrink, what does that affect, and vertical shift. Now you can go into the homework and start piddling around in there if you want, but you're not gonna be able to do all of it yet because I've not gone through all of it. So I would wait till Friday, and I'll do a little bit on Friday, okay? So, what am I talking about vertical stretch, vertical shrink? So here's what I'm talking about. Let's do this, okay? First of all, anytime you're gonna graph, go to mode and make sure you're in radians. So this is an important thing. Always graph in radians. Because, think about our x-axis, it's in radians, not degrees. Don't put it in degrees, okay? So you just make sure you're in radian mode. The next thing, whenever you want to look at a plot, you can do zoom 7. Zoom 7 is your trig zoom. So what do I mean by that is it will do the same x's that we did. Pi over 2, pi, 3 pi over 2, 2 pi. Okay? So whenever you go to look at the graph. So why don't you just do this right now. Go in and graph sine of x. Okay? And see if it looks like what we just drew. If it doesn't, we got issues. We've done it all wrong. We gotta delete the video and start again.
Wait, how do you get to zoom?
Ma'am?
At the top. On the left.
Zoom?
Oh, sorry, yes,
Yeah.
I see.
And then pick 7 and it will go ahead and put a trig zoom for you. Should be like 0 to negative 3 to 3 on the y's, and then it should go negative 2 pi to 2 pi. You should see our normal graph. Okay. So now what I want to see is what we're going to look at. So notice, part 1 done. Developing the graphs of sine and cosine. Have we done that? Yeah, that's all this. Transformations. Transformations means what? What are we looking at? So we've done this part. What do transformations mean?
Like shifting them left and right, up and down.
And how does that occur to the equation? What do you gotta do? Change it, yeah, add numbers. So what we're gonna look at now is, what happens to this if we put a number in front, multiply? So what I want you to do is I want you to track 2 things. What's the amplitude? What's the period? So right now, for sine, amplitude is 1, period is 2 pi, right? For our 1 cycle. So you should have 1 cycle on your, you should see 1 cycle on your screen. I mean, from 0 to 2 pi. Of course, it would graph 2. So I want you to do this. In y2, do 2 sine x. In y3, do do 3 sin x. In y4, do negative 2 sin x. Now look, you probably don't wanna do all these at once, so if you just wanna, I'm listing them all, but if you just wanna change y2 to these, you see what I'm saying? You don't wanna probably put 4 graphs at once, it's gonna get crazy. And then y5, do 1/2 sin x. And let's see what happens to amplitude and what happens to period. And luckily, I have the TI Armand, it just came out, and the TI Armand graph's pretty good, I'm just gonna put it here. Alright, there's sin x. So I don't have to stop and try to graph. And then after we do this, see if it does the exact same thing to cosine. So just change your sine to a cosine and go through and do the exact same thing with that. See if it does all the same movements, okay? So what we wanna do is, I would just do one at a time. I put a 2 in front. What does it do to the graph? Did it change the amplitude? Did it change the period? Okay, and then we'll look at these all at one time in a second. And once we finish these two topics today, we'll be done. Everything good? Finding a pattern? Or you just talking to yourself? I mean, it's okay. I know, just messing with you. Yeah, look for a pattern, chat with your compadres. So it may be a lot to put all 3 or 4 graphs at once. I may just do now, can you determine what's going on? You may have to start deleting stuff.
No, I did them one at a time.
Okay. Yeah. Use my calculator. Alright, and you can also download Desmos. There's an app, you can graph everything in Desmos. It's actually not bad. Okay, so, let's catch up. What happens when we put a 2 in front? Anybody?
Vertical stretch.
Vertical stretch, that's exactly right. The 3 zeros didn't move. This 1 went to 2. This -1 went to -2. And it affected only the graph's what? In terms of the science word? Amplitude, very good. So, a 2 in front does the same thing that a 2 has always done in front. It's a vertical stretch. You're basically multiplying all y values by this number, right? So this is gonna be, so then let's see what happens to amplitude. Now the height is 4, but 4 divided by 2, you should've got 2 for the amplitude. Did it change the width of the graph? Exact same cycle, right? Okay, so period is still 2 pi. Alright, so there you go. So a 2, we saw was a vertical stretch, alright? Well, what happens when we put a 3 in front? Well, then it's gonna get even taller, stretched even more. So we'll just erase that. 3 and -3. It's really stretched. Okay, there's what you should have seen there, right? So what's the amplitude if there's a 3 in front? 3. Everybody see where I'm getting 3? Because how tall is this? 6, but 6 divided by 2, back to 3. What's the period? So, do numbers in front affect the period?
No.
No, because think, only the inside is horizontal, shift and stretch. So since we're not changing the inside, we're not affecting the period at all. Alright, what did a -2 do? It should have done 2 things to the original graph. What are the 2 things it should do? So I'm referring back to the original. So what does a negative do?
Shrunk.
Shouldn't shrink it.
Oh, no, never mind, that was.
Flips it, right? So the negative flipped it and then the 2 stretches it. So what you should have seen is if you went back to your original, the 2 sine x, it should have just flipped that. This dot should have come down here to -2, and this dot should go up here to +2, and you should have seen a graph like this. Okay? It should have flipped it horizontally, right? Because that's what a negative does. A negative in front flips it about the x, see? That's why I call it, look, rotisserie chicken. See, the chicken rotated in a wrap? That's why it's a rotisserie chicken. See, the whole thing flipped, but it also got stretched. But, the question is, what's the amplitude? Still 2. What's the period? Still 2 pi. Okay. Now, the last one, the 1/2, right? Everybody, so far so good. Did anybody get a chance to go in and do this to cosine? If you did, guess what it would do? The exact same thing, so there's no sense, we're just trying to get an idea of what happens. So the last one, let's see. Let's go with light blue here, see what light blue does. So the last one, 1/2. Well, what you should have seen is that y became 1/2, that y became -1/2. So now this last one here, what, can you even see it? I can see it from there. So for the last one, what did a 1/2 do? That would be a vertical shrink, because our crest comes down to here, our valley goes to here. So what's the amplitude for that? 1/2, because this distance is 1, but divided by 2, 1/2, period is still 2 pi. So now, I'm looking for a shortcut. If you have a sine x or a cosine x, what is the amplitude gonna equal? Almost A. You're close. A is almost the right answer, but not exactly. Because look right here.
Absolutely.
Yeah, see, notice, I had a -2 in front, but I didn't put -2 here, I had to put positive. So to ensure we always put positive, we just say what of A? Absolute value. That's always your amplitude. Doesn't matter what else we do, it's still gonna be the amplitude. Okay? Alright. Last thing, I'm not gonna do a lot of these, cause I think you'll know pretty quick. How do we create a vertical shift? How do we create it to move vertically? Think it's,
vertical.
Yeah, vertical, move up and down, move the whole thing.
Just plus or minus.
Plus or minus where?
The end of the equation.
Outside, at the very end. Because think, this is how you get your y's. So if I add a number to the end, it's gonna move the whole thing up and down. So for instance, if we did this, let me do cosine real quick. So I'm gonna erase my y's here, because we got all these. Alright, if I did y1 is go ahead and put cosine x in there. If I did in y2, if I did cosine x, bless you, plus 3, let's see what happens. Let's have a look at it. So I'm gonna go ahead and graph 1, -1, just to save time. There's that. What happens if we do cosine x, but now, this plus 3 is on the outside, okay? Yeah, whole thing moves up 3. So what you should see is that the peak is at 4. I don't know if you have to change your window. And at this valley, if I move it up 3, it should be at 2. It should be the whole picture there. The whole thing should move up 3. That's what you should get. Now here's what I want you to see. If I did y3, if I did 2 cosine x minus 1, it's not going to change the amplitude. So the first thing that'll happen is it will stretch, then it just moves down 1. But the amplitude should be what? 2. Even though you put a -1, it doesn't stretch it anymore, it just shifts it. So we'll calculate and see. So see if this actually does shift down 1. Alright, does it move this picture down 1? Let's see. So go ahead and graph that real quick. So I'm gonna graph as my basic. I'll graph 2 cosine x as my basic graph, and then we'll do the shift. And then we'll be done after this, okay? Do this last one. Not the best cosine, but that's 2 cosine x. So what you should see when you go to do a -1 now, it should go here and here, and then this should be down at -3. So what I want you to see is it didn't change the amplitude. So Haley, how far is it, Haley L, how far is it from here to here? What's the distance? Here to here.
Is it the 1 or?
Yeah, to 1, sorry. Like from the bottom of the wave to the top, how far is that?
5?
Let's see, 1, 2, 3. Look, you're going from -3 to 1. How far is that? Alright. Let's count. 1, 2, 3, 4. -3 to 1 is 4. Okay? So, what point am I trying to make? The amplitude. How do you get it? It's height divided by 2, which is still 2. By doing a subtraction, does it change the amplitude? No. So the number in front always tells you amplitude. Doesn't matter what you do at the end. Because it just, after I've stretched it, it just shifts the whole wave. So the amplitude on this is still 2. Okay? The -1 didn't affect the amplitude. All it did is just move the picture down 1. Okay? Understand?
Okay.
Alright. So, what does the number on the end do? Shifts it up or down. Okay? Some people give this, I forget what they call this. The middle of this, the mid-axis or something, I don't know what they call it. They move that. I don't move that. I leave that alone. Like they'll say, okay, well now the middle of the wave's here. Well, I don't highlight that. I don't. Okay. So, part 1 is done. We'll continue with part 2